Good morning. Thank you for the introduction and thank you to everyone for being here. I want to say a special thank you to the Research Landscapes team for making this event, putting it together. They did a great job. I want to introduce myself starting out on a personal level so you know how I got to where I am today. Growing up, this is the house my parents built in the woods in Western Washington. At the end of a dead-end road on 40 acres. And fire, honestly, wildfire never crossed my mind in this wet environment. We did have a wood heat. Wood heat was our only source of heat, though, and our roof caught on fire a couple of times. They now have a metal roof. I had an early interest in the natural world, and so I went on to study public policy and biology in college. After doing a series of random ecology-related jobs, I decided to go back to graduate school and study fire and drought, which were the big issues I thought were facing the West. And that's where I wanted to spend my career. So I did that at Northern Arizona University in Flagstaff. And I've been here teaching and studying fire ecology and management in Utah for 4 years. Just last year, my parents had a small fire burn near their house. It actually cut the way off out of their dead-end road location. Luckily, it stayed small and no damage was done to their house, their property, or anybody else on the road. But they're having to think about fire in a new way, as a new reality. I'm really excited to be here. I know we have a range of audience members, from people who think about fire every day to those who don't consider it very much. And so I found it a little bit difficult to tailor this talk. Also, I know, I can talk about fire for a whole semester. I teach a class on fire at Utah State. And so I'm having to skim through things and simplify things. So if there are things that I miss, I'm looking forward to the discussion at the end and time for questions. And I'll look forward to hearing what you think. So every year we hear about disasters, and the disaster, the number of disasters seem to be increasing over recent years, with burnt cars and homes, terrible air quality, red skies, hundreds of thousands of people evacuated. And we're not immune to these disaster fires in Utah either. We haven't had the catastrophes that, on the scale of those that other states have had so far, but there are currently fires burning already, and we know that there will be more this year. But as someone who studies the ecological role of fire, as well as how we can manage forests to reduce the negative impacts of fire and try to promote the ecological benefits of fire, my goal today is to convince you that, first of all, there isn't really an option to not have fire on a landscape. That's not a choice that we get to make. Second, not all fire is bad, and so that's a good thing. And then third, some of you may even be convinced by the end that more fire on our landscapes could help us out of the situation that we're in. So let's start with the first one. We don't have the option of no fire. Fire has been around on Earth as long as there were enough plants growing, they form the fuel for fire, and enough oxygen in the atmosphere to support combustion. So fire has waxed and waned in how much fire there was over the past 420 million years, but it's been here long before humans, and will be here as long as there's enough fuel and oxygen. Second, fires burn all over the world. This is a map showing fires picked up by a satellite over the past week, and you can see they're everywhere. The Western US is not unique in supporting fire. A lot of these fires are likely agricultural, but some of them are wildfires. And the point is that, fire is really widespread as both a tool and as a natural process globally. The last point on this section is that no matter how sophisticated our suppression gets or how much money we spend trying to suppress fires in the West, in the United States, we still see, we still see more acreage burning. And so this blue line shows the amount of money we're spending on suppression alone over the past 3.5 decades. And we hit over $3 billion for the first time in 2018. You would think that that might translate to less acreage burning, but the red line here shows acres burned. And you can see that that's increasing with the costs. So again, I think that those points go to this first takeaway, is that we don't have the option of living in a world without fire. We were lucky for the 20th century in some ways, and we got used to this idea that we could get rid of fire, but it's not really an option. So that leads us to the second takeaway, which is that living in a world with fire doesn't necessarily have to be a bad thing. So I kind of want to introduce this idea of categorizing fire impacts, going beyond the idea that all fire is bad, or even fire is good or bad. I think we can look at fire on a couple of different axes, thinking about fire impacts on ecosystems and also fire impacts on people. This is still a simplistic way to look at it. I mean, some fires could have a combination of good and bad impacts on ecosystems, for example. But I think the idea of incorporating both ecosystem and human-centered perspectives will be valuable. So to kind of get into that a little bit more, I want to introduce the idea of a historical fire regime. The concept of a fire regime means the type of fire that occurs naturally depending on the fuel and climate of a particular place. Let me give you some examples. On the left here, you see an example of an ecosystem that historically supported low-severity fire. The classic example of this type of forest is a ponderosa pine forest. We have those in southern Utah, also over in the Uintas. And in these types of forests, low severity means that the fires didn't typically kill a lot of the adult trees, and they were frequent, sometimes as often as every 5 to 10 years in some forests, some of these dry, open forests. And the ponderosa pines in this example have thick bark that allow them to survive this type of fire. So this surface fire, it burns through the grass and pine needles on the forest floor. The heat is kept out of the living part of that trunk of that tree by the thick bark. And also these trees self-prune. That means they drop their lower branches. And so it's difficult for fire to get up into the canopy when it's an open forest without a lot of fuels close to the ground. On the right is a different type of forest that would have historically supported high severity fire. So these types of forests are usually higher elevation, wetter. There's a lot of fuel there, but they're typically too wet to burn. And so examples would be, mixed conifer or aspen forests in central Utah, or up higher spruce mixed with fir, and lodgepole pine farther north in the Rockies as well. So in this case, fire would have historically burned at high severity, meaning lots of mature trees would be killed, and they would be very infrequent. So every few hundred years, potentially 100 to 300 or more years between fires. And then most places, really, those are two ends of the spectrum, but most places historically experienced mixed severity fire, where there was a mix of low and high severity, creating kind of a matrix of dead trees, live trees across the landscape. Okay, so I've introduced the idea of a historical fire regime, and now I want to talk about how individual fires match up with those regimes or not. Okay, so let's dive into that. So here's an example of a fire that burned recently in New Mexico. These are ponderosa pine trees in the background, and these mature trees survived that low severity surface fire. They probably actually survived dozens of these fires throughout their lifetime. These are old trees. So this fire matches well with that historical fire regime, and these trees have traits that allow them to survive this event. Here's another example of, this is a high severity fire. This is actually in the Uintas in Utah, where it was high severity, but the trees here also have adaptations. And the aspen is resprouting from the roots, and the patches of high severity are not large enough that conifer seeds can't get back in. And there's actually a lot of conifer seedlings coming back in this area as well. And so this is another case where the current fire matches up with the historical fire regime, and these trees are able to return post-fire. So both of those fires I would put on this part of this figure. So they have a positive benefit for the ecosystem, and they're good for people as well, because there were no damages to any values for humans, and also we reduce the future fire risk in these areas, future high severity fire risk or damaging fire risk. Okay, here's another example that many of you are probably familiar with, the high-severity fires in Yellowstone in 1988. In this case, similarly to the last figure, a lot of the mature trees that you can see in the field of view in this picture did not survive, but their offspring did. So ecologically, this, for the most part, this was not an ecologically harmful fire. There were some buildings burned, and this also really shocked the country. And so, it was devastating to people who saw Yellowstone burning. And so I would put this fire into this quadrant here, where overall there were positive, or, the effects on the ecosystem were not harmful. However, there were some buildings burned and people were upset. So we can put that in the negative impacts on people. Damage to lives, property, and watersheds potentially would go into this category here of negative impacts on people, but the ecosystem is adapted to the type of fire that occurs. Here's another example of a high severity fire. This is back to New Mexico, where the very high severity and the trees in this location don't have adaptations to either survive the fire or to come back after the fire. So there are very long distances to seed sources. There were also watershed damage in local communities and some flooding. And so this would be an example in this negative for on both axes. Not good for people. It's not really good for the ecosystem. This place would take maybe hundreds of years to come back as a forest, or maybe never with where we are with climate change right now. So again, atypical fire where plants are unable to persist through would be what I think of as a negative impact on the ecosystem. And then, of course, for people, damage to lives, property, and livelihoods. I want to take a little bit of a side note to talk about what true loss of forest is in a fire. So I hear a lot of times that, for example, 20,000 acres of forest have been lost to a wildfire. For the most part, we don't usually actually lose forests to wildfires, because as long as there's tree regeneration, it's not a loss of forest, it's just a reset to a younger stage of development. But in this picture here, you can actually see real loss. This fire burned in the 1990s. And so it has converted from a forested ecosystem to a grassland. And so there's a loss here of carbon storage, habitat, recreation value, and other values that humans hold dear. But I just want to mention, just as an ecologist, it's still a value judgment that we put on this, because even though losing forest is something we want to try to avoid, in this case, the grasses are still benefiting from this conversion. So just recognizing that even the negative impacts to an ecosystem involve some human judgment. I also want to highlight some Utah State University research ongoing in this realm. So one of the projects that is ongoing is we're looking at what predicts successful post-fire forest regeneration. Another type of research, another project that we're working on is what are the interactions between animals and post-fire vegetation. I'm working with a wildlife ecologist here in my department, and we have a student who's co-advised by both of us looking at those interactions. And then finally, I have another student interested in how we can use satellite data to better detect fire burn severity patterns, and how those are related to these questions of what comes back after fire. Okay, so we've gone through these three quadrants on this graph here. So what goes in this final one, where we have a positive impact on people and something not great for the ecosystem? Okay, so to answer that, I'm going to back up in time and walk through how we got to where we are today. So a couple hundred years ago and beyond, farther back. We know from oral history and other sources that Native American fire use was extensive and frequent across the West, and actually across the continent. They used fire to clear agricultural fields, drive game, wage war, and sometimes to promote particular plants that thrive after fire. There were also frequent lightning starts, and we don't know the exact numbers, the exact proportions of fires that were started by people versus lightning, and it definitely would have varied by location. But we do know that there was more fire historically than we see on our landscape today. One of the lines of evidence for this comes from fire scars that are preserved in the rings of trees. this is an example of one tree that survived 11 fires in its lifetime. And you can see these are all the dates of the fires. And so you can see there were, just over a decade in between several of these fires, and then a long hiatus between 1911 to 1996 when this tree sample was cut. And so this type of sample is really common in those dry forests, like I was talking about, such as ponderosa pine forests. You can see how frequent fires were historically by looking at this kind of evidence. In the late 1800s and early 1900s, there was a national debate between people who thought fire was a waste of our country's natural resources and those who thought that fire was a useful tool. In 1910, what has been called the Big Burn occurred, and this was an event. There's actually multiple fires, but they burned about 3 million acres across Montana, Idaho, and other parts of the Northwest. And these fires burned entire towns to the ground. They killed dozens of people. They sent fire all the way, or smoke all the way to the East Coast, and really shocked people. And so that kind of settled the debate between the fire suppression and the fire use sides of the argument. Suppression was seen as a good idea. We should not let these fires waste so much of our natural resources and cause such destruction. So we entered what we can think of as the fire exclusion age, where fire was really successfully eliminated from our landscapes. This is a graph showing, it's actually, this data is from charcoal influxes. So this is not my research, but it's a publication showing the amount of fire that's biomass burning over the past 3,000 years. So on this down here, there's an axis showing present day back to 3,000 years ago. And on the top is actually the year values. So year 2000 is right here. And you can see in this purple box here is from 1900 through the end of the century, we really had this decline in the amount of biomass burned across the West. And it actually, by the end of the century, it was lower than it had been any time in the past 3,000 years. This is from a different paper also showing area burn just in the 20th century. And it shows that by the 1950s, we were really pretty good at eliminating fire from Western landscapes. And this kind of loss of fire from, as an ecological process has been called the fire deficit, which I think is a good term to use in thinking about how big of a role fire used to play across this country, and now how little of it we have today. So you might be wondering why I'm calling it fire exclusion and not just fire suppression. There's actually several reasons for the several factors that went into such a loss of fire from our ecosystems. One of them was the completion of the railroads in the late 1800s. The railroads allowed livestock to be grazed in high numbers across the West and then shipped back to a market on the East Coast. There weren't enough people in the West to eat all of those livestock, but once the railroads were finished, they could send all these animals back. And what those high numbers of grazing animals did was basically eat the fine fuel that had supported frequent fire in those infrequent fire systems. We also had a lot of logging going on at the end of the 1800s and early 1900s, which changed the fire dynamic. In the 30s, a policy called the 10 a.m. policy was put into place that required fires to be put out by 10 a.m. the day after they were found. And then what really started to really change things was the return of people and equipment from World War II. And some of those men and equipment really allowed the aggressive fire suppression and very successful elimination of fire. So what happened during that fire exclusion era is that several things happened. We had the population in the West increase dramatically, all across from cities to rural areas. And I'll bring up the term wildland-urban interface here now for the first of many times I'll talk about it today. That grew dramatically. I don't have good numbers before 1990, but this is just showing the amount of area in the wildland-urban interface, the number of housing units in the wildland-urban interface, and how many millions of people live in it, just in the changes just from 1990 through 2010. And I think that, just a little bit more background on the wildland-urban interface. There are a couple types of wildland-urban interface, also called the WUI. There's interface WUI, where structures are adjacent to wildland vegetation, and then there's intermix WUI, where structures are intermingled with wildland vegetation. You can think about cabins nestled into the woods for this kind of WUI. I think another really important thing that happened during the 20th century is that people got used to living in a fire-free world, and they really thought that that was the natural state of the landscape. There were ecological changes that happened as well. So forests that historically supported frequent fire became more dense without that frequent fire to keep the small trees out and keep the forest fairly open. Here's a photo from 1909 showing a pretty open forest. You can see how fire would have just spread through the surface fuels in this forest, and lots of wide open space between these mature trees. Here's the same location from 1949. And you can see a lot of small trees are starting to infill this open space. The same two trees you can see here in the background and this leaning one over here. And then the last picture is from 1994. You can barely see those same trees from the same location now, because all of these trees are now several decades old, and really making this forest more dense than it was historically. So in dry, frequent fire forests, currently, many of them look like this. This is called a dog hair thicket. It looks like dog hair. It has more ladder fuels. Ladder fuels allow a fire to get from the surface fuels up into the canopy, and it has higher fuel loads overall. In wet, infrequent fire forests, fire has always burned infrequently. And so at any given location, we can't point to a spot and say that a particular forest has missed a fire. They've always had high fuel loads. The change that has happened, though, is really at a larger scale. So you have to back out and think about the entire landscape. What's missing are some of those fires that surely would have burned through the 20th century and created a mosaic pattern or patchy, more heterogeneous forest across a larger scale. So that's what I would put into this fourth box. I would put these forests where they have, we have, in some cases, more fuel, in some cases, less heterogeneity. We've lost that kind of diverse, patchy mosaic across those wet, infrequent fire forests. And so we've got no fire in ecosystems adapted to fire. And so I would count that as a negative for ecosystems. And then, it's in this kind of positive side of the scale for people. But on the other hand, I think it's a false benefit, because we've just put those fire impacts off, and we still have future fire risk that's very high. So there's an asterisk here, whether this really is a benefit or a false benefit. So that leads us to where we currently are today. We do have a buildup of fuels in some ecosystems. Here's another interesting contrast between 1870 with a sketch of a landscape, and then a photograph of the same place from the 1990s. So that's true in some ecosystems. We also have climate changing. We have warmer temperatures. We've already seen, average temperatures are higher now than they were decades ago. We have increasingly severe drought, and we have longer fire seasons, partly due to earlier snow melt, which gives greater potential for fires to burn during the fire season. On the right, you can see a graph showing the fire season length over different decades from the 70s, and then how it has increased. From the 70s to the 80s, the fire season increased by 42 days, and then 24 days the next decade, 26 days the next decade. So, and these fire seasons are measured by the days between the first and last fire greater than 1,000 acres. And we also see fire damage increasing. This is looking at structures destroyed by year from 2005 through 2020 across the United States. And there have been almost 90,000 structures destroyed. And you can see some of the biggest fire years have been really recently. 2018 was the worst one so far with those horrible fires in California. If you're interested, this is the data from Utah. There have been about 1,000 structures destroyed in this 15-year period, and 2018 was also the worst year here in Utah. Okay, so where does this lead us? Where do we go from here? I think what we have to think about is back up and think about what we're trying to prevent. So I think what we're trying to prevent is fire-related damage to homes and communities, watersheds, and other high-value resources. So, that means damage to the places we can't afford to use. And I'm carefully using the word damage here versus severity, because fire itself is not a reasonable thing to try to avoid, even high-severity fire. That said, we probably also want to try to avoid really large high-severity fires. There's the increased potential loss of forest resilience in those cases, and also potential for lack of control of those fires and damage to valued resources. So the first thing that has to happen is preparing our communities. This should be the #1 priority in those WUI areas. Most houses are ignited by embers from a fire. They're not burned over by a wall of flames. And that means that doing things like screening in vents and cleaning gutters, those actions actually work. They've been shown that they work. This also, preparation at the individual homeowner or community level also has the effect of not leaving all the responsibility of protecting communities to firefighters. There are a lot of resources for how to fire harden a home and landscaping, including national programs, as well as information specific to Utah available through Utah State University Forestry Extension. So I'm not going to get really into the details today, but this is a really crucial topic when we think about how to prepare Utah for fire in the future. There are also things we can do in wildland areas. So preparing our lands for fire. And again, preparing them, we know fire will burn. And so how can we prep our lands for those inevitable fires? So to start, thinking about how you would do that, I think the first thing to think about is how would fire behave in this landscape. And actually, this is a photo from above Bear Lake. You could see Bear Lake here in the background. So there are 3 legs of what's called the fire behavior triangle. The first, and the fire behavior triangle is what influences how a fire behaves. Fire behavior is things like flame length, heat output, rate of spread, how fast it moves across the landscape, and whether it's burning in surface fuels or up in canopy fuels. So the first thing that determines how fire behaves is topography. And an example of that is that fire moves more quickly up steeper slopes, tends to move more quickly up than down. And if it's steeper, it moves even more quickly. The second leg of the triangle is weather. It's another leg of the triangle. And an example of this is that fire moves more quickly with stronger winds, for example. And then the third leg of the triangle is fuel. And so fuel is the one leg of the triangle that we have some control over. I will say also that there's a flame depicted in the center of this triangle because fire can influence its own behavior. If it gets big enough, it can create its own pyrocumulus clouds, for example, but that's another thing we don't have a lot of control over. So fuel, that's basically fuel loads, how much biomass is out on the landscape and what arrangement is it in? Is it in trees? Is it in logs on the ground? Is it in fine pine needles on the ground? Those are the things that can be changed in a landscape by managers. I will note that fuel treatments are not designed to eliminate fire from landscapes. Again, it's not a reasonable goal, and it's not very, it's a kind of a counterproductive goal as well. So the thing that is recommended that people are trying to do if they're wanting to change fuel on the landscape is to reduce the risk of future atypical fire, not eliminate fire altogether. So when you think about what the options are specifically, again, we have to go back to the fact that we have multiple types of forests in our Western landscapes and in Utah. We've got dry open forests, and in those areas, thinning trees, so cutting some of the smaller ones, and then followed by prescribed fire. That combination has been shown to be very effective in reducing the fire behavior of subsequent wildfires and also reducing severity. In high wet forests, it's not as straightforward. It doesn't, it's not actually a good idea to thin in those areas. You can actually increase the rate of spread if you do that, because you would allow those normally wet fuels to dry out and wind speed to increase under the canopy. So you could actually have the effect of increasing fire rate of spread if you thinned in some of these high wet forests. But some of the recommendations are to break up the landscape. So try to create that patchy mosaic that we're missing after a century without a lot of fire. Diversify age classes. Try to get some young trees in there, which are harder to burn than old, crusty, dried out trees. And then intermediate forests, mixed tactics between these two extremes, and also trying novel and experimental approaches. There's been a lot less work done in intermediate and high elevation forests. So I think we still have some work to do to understand exactly the best way to prepare our landscapes for fire that will happen in the future. This leads me to some other ongoing Utah State research. We have several projects ongoing to try to understand the effectiveness of fuel treatments. One project is looking at what forest management actions would best protect downstream reservoirs. This is a project that I'm working on in collaboration with some colleagues in the Watershed Sciences program. We're also looking at when and where do aspen forests change fire behavior and effects. Firefighters are well aware that aspen can actually be difficult to burn. It's been called an asbestos forest. And so we're looking into the details of that, because we've also seen places where aspen has burned through in a crown fire. So trying to dig into the details of when and where aspen does work as a fuel break, and in hopes that that might be something to try more of here in Utah. And then finally, we're looking at whether fuel treatments are effective in meeting objectives in Utah using a broad scale approach. And here I have a video to share with you, highlighting the work of one of the grad students in my lab.
Hi, my name is Jamila Thompson, and I'm a grad student in the Fire Ecology Lab at USU. Today, I'm in Providence Canyon to show you some of these treatments. So we can see here that this area was opened up where it used to be encroached by juniper trees. This is an example of cut and pile, and later this pile will be burned so that there's not such a heavy fuel load if a wildfire were to come through. So there are a few things that limit how and when we can do fuel treatments, and that includes funding. It includes having personnel available, because often firefighters are concurrently committed to wildfires during the weather windows. So the bulk of my data comes from publicly available data sources. The Forest Service and the BLM have spatial data portals. And so I have that, and I've collected my field data. So now I'm in the analysis phase to ask questions such as, how do fuel treatments affect burn severity when encountered by a fire? And I'm also looking at proportions of wildfire sizes and treatment sizes. I'm looking at those relationships where wildfires might burn up right next to a treatment, because that still means that they were effective in that way. So I'm using multiple metrics of effectiveness to look at fuel treatment. The results from my research can help inform land managers on how best to optimize fuel treatments and resources.
Okay, so there are some things I want to say about fuel treatments. One is that, as I kind of already mentioned, forests can't be fireproofed. Fire will still burn even in treated forests. So that's something I think we need to make sure everyone knows. Also, vegetation grows, of course. And so once a place is treated, that doesn't mean that it's good forever. Repeat treatments have to be done in order to keep a place meeting the objectives of the management. And then, as I already kind of alluded to as well, there isn't a one-size-fits-all treatment. The wrong treatment in the wrong place can backfire and actually either increase fire behavior with a future wildfire or even reduce increase severity. For example, if a place is thinned, but the surface fuels are not cleaned up through pile burns or something like that. Finally, fuel treatments are really a useful tool, but they're not possible at the scale needed. When you think about how many millions of acres across the West and in Utah are ready to burn, fuel treatments, they're expensive, and we're just not getting there quickly enough. In fact, every year we are falling further into that fire deficit. So the bottom line is that fuel treatments are a very useful tool. They're great, but they're not a panacea. They will not solve this dilemma that we have. Okay, so that leads me to the third takeaway from today, which is that more fire could help. More wildfire might help, actually. So prescribed fire, of course, but then also wildfire itself, if it's not the ecologically destructive fire that also does damage to human communities. So right now, we can think about the fact that we have some choice in the type of fire that we get to experience. And so there's this horrible, scary fire that's in the news all the time. Those are the fires that are actually impossible to put out. Otherwise, we would have put them out. So kind of by definition, that's what's currently still burning. And the greatest acreage is burning in those most extreme conditions. Those are the conditions that are hot, dry, and windy. And in fact, over 90% of area burned in the Western US is burned in less than 3% of fires. So these horrible, scary fires are really accounting for almost all of the acreage. If you think about what would constitute a helpful wildfire, well, those would be probably burning under more moderate conditions. And I'm saying optimal here because in some cases, some wind is helpful. It's a little bit tricky sometimes to burn under mild conditions because under truly mild conditions, it actually can be hard to get a fire to go. I've heard about fires in Utah that were left to their own devices for a couple of weeks just because firefighters were absolutely swamped dealing with fires elsewhere. And they got up to something like 9 acres or 30 acres. They had a hard time actually getting any getting going. So those are, under mild conditions, it can be difficult. But when and where appropriate, and there's been a lot of success in some parts of the West in recent years, fires can be managed for ecosystem benefit. What this might look like is actually having 2 flanks of a fire managed in different ways, where one flank is managed with full suppression, and another flank is allowed to meander through the vegetation and burn itself out, or reach some kind of containment line to do some work in the wildland far from where human values. What's also required for this to work well is to have some pre-planning done. So there's this idea, people have been doing to map out exactly where a lightning strike would have to land under, just what great conditions in order for a fire to not be immediately suppressed. So when you have that pre-planning done, then good decisions can be made quickly. And ecosystem, fire can be used to get us out of this hole that we're in and play a helpful role in the ecosystem. Okay, so the basic idea of this, my trying to convince you is that just back to the first 2 points, we don't get rid of fire. And so what we would want to do is move fire from where it's having a negative impact, either on homes, communities, people's lives, and ecosystems, into this box where we don't have damage to human communities, watersheds, livelihoods, and we also reduce future fire risk. And then for the ecosystem, we have fire burning in these ecosystems that are adapted to fire. I recognize that this message is, it's sort of timely, but it also might sound ridiculous right now. We're in this beginning of a very, record drought. It's been extremely hot. We already know that we're not going to come out of 2021 unscathed. Definitely we'll have some disaster fires across the West. We don't know exactly where, but it's pretty, I think we can be sure things won't go well for everyone this summer. So the idea of having more wildfire on landscape might not sound reasonable. However, if you step back, out of this particular year, fire is probably the fastest, sometimes the cheapest, least red tape way of trying to inch our way out of this mess that we're in across the West. I will say there are a couple caveats to this. So wildfire, first of all, extreme care is taken in every one of these situations where fire has been successfully managed for ecosystem benefit. Usually that's not a good idea. Right next to the WUI, for example, there are other places where suppression is probably still our best bet as well. And one example of that is across most of the Great Basin that's vulnerable to cheatgrass invasion. Cheatgrass is an invasive grass. It thrives with fire, and it actually promotes fire in return because it cures earlier than the native grasses. And so what can happen is that in these ecosystems, fire returns more quickly than the native plants can deal with. And so in those cases, it makes sense to probably continue to suppress fire in those places or other places where an invasive grass or other plant that loves fire is going to return or increase if fire is allowed to burn. Other places where suppression might still be the best option include old growth forest, riparian habitat, or other important habitat. The other really important caveat here is that regular human caused fire, so members of the public, still not a good idea. We still don't want to see human caused fires out on the landscape. Those are actually not even allowed to be used for ecosystem benefit. And in fact, human caused starts. So things like campfires, vehicles. The picture here is a gender reveal party gone wrong. Human caused fires actually cause the most home burning wildfires. And so those are still really important. The message that we should put out our campfires is still extremely relevant, and education is really important to try to get people to be careful with fire. So that's still also a really important message to get out there. So those are all really straightforward, recommendations that a lot of people would agree with. I think I wanted to just take a chance here and put out some things that I don't know how possible they are on a short-term basis, but these are other ideas that I think if I were in charge for a day, these are other things I would consider. And just for a day, I don't really want to be in charge permanently. I would increase the budget for field treatments and prescribed burns. That's kind of a no-brainer. I think we need to spend more money on preparing landscapes for fire instead of trying to suppress fire, or more than we do now. I think there's a lot of agreement about that. I would loosen smoke restrictions for prescribed fire. That's one of the things that prevents more fire from being prescribed fire from being used in Utah, although there are other barriers as well. And actually, I think this is happening. I think in Utah, there is a push to try to make those smoke regulations a little bit less rigorous. I would also try to think about how we can reduce the ever increasing risk of homes in the WUI and reduce it somehow. So one idea would be to actually purchase undeveloped WUI land. I have no idea if this is possible, but thinking about the fact that I think WUI is one of the big, wildland-urban interface is one of the big challenges to the way that we manage fire now. We're sort of locked into trying to suppress fires so that we don't damage homes and communities. And so if we could, stop putting more wildland-urban interface out on the landscape, I think that would be something for economists to try to figure out how we can do this. And then, new construction requirements. If there are going to be new buildings built in the wildland-urban interface, then require, certain guidelines to be followed. And this could happen either through regulation or it could happen through insurance incentives. So, and this is happening in some areas around the country as well, where insurance companies are not insuring houses unless they meet certain requirements. Here's the most, I don't know, maybe out there idea, which is to create an adaptive management designation on public land. So you've probably heard of wilderness designation, places that are designated wilderness. I was thinking about like, what if I were a manager, what I would want to do. And I think one of the things that I would want to do is try things. The idea of adaptive management is where you try something, you monitor how it goes, you see what works, see what does not work, and try something different as a follow-up. It would allow, thinking through how are we going to, I just think more experimentation, more creativity would be valuable. And so, this idea for allowing a proportion of public land to be managed experimentally, I think would be really interesting. Okay, so back to the takeaways. I hope you are convinced there is no fireless option. And I think most of you already know not all fire is bad. And also more fire, both in the form of prescribed fire and even wildfires, could help. And I have also added here at the very end, I think we need new ideas. I'm not sure if anyone would agree that right now, the way that we're managing fire is going great. So I think without being too harsh, I think that new ideas are really going to be crucial over the next couple of decades. Not just fire, but thinking more holistically about our forests across the West and in Utah. We've got climate change already happening. The fire, forests are facing more than just fire. They're also going to be facing challenges in the form of insects and disease and drought. So I'll just leave you with this idea of, in thinking about the future of our forests, there's the idea of helping our forests resist change. So that means not changing at all, even in the face of challenges. Be resilient to change. That means that there may be a disturbance come through and then they can come back from that. And then the third idea is helping our forests adapt to change. And that might mean changing the species that are on the landscape or other more forward-thinking solutions to some of the challenges that we're looking at over the next couple of decades. I do think that the old ways that we've been doing things are not going to continue to work for us. So the, just 10,000 foot view here, I think that creative solutions are going to be necessary over the next century. So I want to thank you for your attention and your time. Again, thanks for the invitation to give this talk today, and I'm interested to hear any thoughts and questions that you may have.